In this video, we're going to learn how to precisely describe the rigid transformations that we need to move one object onto a second object to prove that they are congruent. And we're going to use the CoolDown from lesson 13 of Illustrative Mathematics. So what we want to do is we want to take this shape which I've traced and move it to this image down here using rigid transformations, and by doing that and seeing that it exactly fits, we prove that they are congruent. And you can tell which is the original and which is the image because the original just has letters A, B, C, D, and the image has these little ticks after the letters, which we call a prime. So it has A prime, B prime, C prime, D prime. And that's how we differentiate between the original with no primes and the image that has primes. All right, the way I recommend you do this is you always start with a translate, and then you do a rotate, and then you may need to do a reflection, but sometimes you don't need it. So we're going to start with the translation, and the object of the translation is going to be to get 1 point on the original to be in the correct place where the image is. So in this one, it looks like the easiest way is for me to move B down to B prime. So I've drawn a red arrow there to show how I'm going to slide B down to B prime with a translation. So this arrow is a directed line segment, which is a fancy way to describe an arrow. So if I was going to translate this shape along this arrow, the way I would describe that in English is I would say translate, and then I have to say what I'm translating, A, B, C, D, and then I have to say what line segment or arrow I am translating it along. So I'm going to say by directed line segment B, B prime. Another way I could do this is I could say translate A, B, C, D until B is on B prime. So that's a little shorter way to do it, but this is the most rigid way to do it. Okay. So now I have B in the correct place, so I want to make sure I don't move B. So now my object with my second transformation is to get a second point in the correct place. So right now, B is in the correct place, A is up here, and A prime is down here. So I could get A into the correct place by rotating like this. So that's one option I have. Another option, C is up here, and it needs to move to here. So another option is I could rotate like this, and I could put C into the correct place. So I get my choice which one I want to do. So I'm going to put A in the correct place. So I'm going to rotate around B, because I don't want B to move, until A is on A prime. So there's a couple ways I can describe that. I can use an angle, and I'm rotating this far, which is 120 degrees. So I can say rotate A, B, C, D, and this direction is counterclockwise. So I could say 120 degrees counterclockwise. So that's one way I could say it. the other way I could say it, which is a little bit easier, where you don't have to know what the angle is I could say rotate ABCD around B. Oh, I forgot to say around B. It's very important to say what you're rotating around. So I could say rotate ABCD around B until A is on A prime. So my option 2 is say rotate ABCD around B until A is on A prime. All right, so now I'm down here. And with the reflection, so I'm either already done or I can finish up with a reflection. So if I reflect across AB, then that's going to just flip this thing over like that, and it's going to be in the right place. So when I want to do a reflection, I need to say what I'm reflecting. So I need to say ABCD, because that's what I'm reflecting. And then I need to give a line of reflection, which is the line that I'm flipping across. So I'm going to say across AB. So that means I use AB as my line of reflection, and I either fold the paper or I flip the paper over, and I'm done. My two shapes are on top of each other. I only used rigid transformations, and it exactly fits, so I have proved that they're congruent. And it will always work if you do it in this order. If you start with a translate, and then do a rotate, and then do a reflection if necessary, that will always work.